Two objectives in this section: find a related rate, use related rates to solve real-life problems. You have seen how the chain rule can be used to find dy dx implicitly. Another important use of the chain rule is to find the rate of change of two or more related variables that are changing with respect to time. For example, when water is drained out of a conical tank, the volume V, the radius R, and the height h of the water level are all functions of time t. Knowing that these variables are related by the equation V equal to pi over 3 r squared h. You can differentiate implicitly with respect to t to obtain the related rate equation. So we differentiate the equation with respect to t on both sides. So for left side, we differentiate the v with respect to t by using the implicit derivative. Where for the right side, we differentiate pi over 3 r squared h with respect to t. We use product rule. Because pi over 3 is constant, but r and h are variables, and the r squared and h, they are in product form. So we say the r squared is the first function, and the h is second function. So this step, the main rule is product rule. We differentiate the second function implicitly times first function plus we differentiate the first function implicitly with respect to t times second function. And then we simplify. So from this equation, you can see that the rate of change of V is related to the rate of change of both H and R. Suppose x and y are both differentiable functions of t and are related by the equation y equal to x squared plus 3. Find dy dt when x equal to 1, given that ds dt equal to 2 when x equal to 1. Using the chain rule, you can differentiate both sides of the equation with respect to t. We write the original equation and we differentiate both sides of the equation with respect to t. So we have dy dt equal to 2x dx dt. When x equal to 1 and dx dt equal to 2, you have dy dt equal to 2 times 1 times 2 equal to 4. In first example, you were given an equation that related the variables x and y and were asked to find the rate of change when x equal to 1. In the next example, you must create a mathematical model from a verbal description. A pebble is dropped in a compound, causing ripples in the form of concentric circles. The radius r of the outer ripple is increasing at a rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area A of the distilled water changing? The variable r and A are related by the area of the circle, A equal to pi r squared. And also based on the verbal statement, the rate of change of the radius dr dt equal to 1. And in question, you are required to find dA dt when r equal to 4. Look at the solution. Differentiate the equation with respect to t. And we use implicit derivative to get the dA dt function. And when r equal to 4 and dr dt equal to 1, so dA dt equal to 8 pi square feet per second. And we can conclude our answer. When the radius is 4 feet, the area is changing at a rate of 8 pi feet per second. The guidelines for solving related rate problems. First, identify all given quantities and quantities to be determined. Make a sketch and label the quantities. Write an equation involving the variables whose rate of change either are given or are to be determined. Using the chain rule, implicitly differentiate both sides of the equation with respect to time t. After completing step 3, substitute into the resulting equation all known values for the variables and their rate of change. Then solve for the required rate of change. This table is showing us how to translate the verbal statement to mathematical model.